Hello everyone. So in this video we would be discussing questions 11 to 20 of IBSL Chemistry Paper 1 of year 2020. We have already released the first video which contains the solutions of question 1 to 20, and I would be attaching the link of that video in this description. So let's start with the first question. So in this question, we need to correctly identify the geometry of the carbonate ion CO3 2 minus. So firstly, to solve these questions, we need to identify the hybridization of carbon. Okay. So how for hybridization, we would be using our general formula, that is half of. Firstly, we would be calculating the valence electrons of carbon, that is 4 plus there is a 2 minus charge here, so plus 2 minus 0, there is no positive charge, and there is no monovalent atoms attached to it. So the value of Z comes out to be 3 and the hybridization becomes sp2. Okay. As it is sp2 hybridized, I can say that the electron geometry is trigonal planar. Okay. So either of option A or option C would be correct. Now let's check the number of lone pairs. Okay, so lone pair would be the value of Z minus the number of neighboring atoms. So for this carbon, number of neighboring atoms is 3 because you have 3 oxygen here. So Z minus 3, so number of lone pairs is 0. When the number of lone pair is 0, your molecular geometry is same as the electron geometry. So as a result, option C is the correct answer to this question. In this next question, we need to find out the correct order of metallic bond strength. So to solve this question, we need to know the charge by size ratio. Okay, so the greater charge by size ratio is, the greater is the ratio, the stronger would be the metallic bond strength. Okay, so we have sodium, potassium, rubidium, magnesium. Okay, for the charges, sodium, potassium or rubidium, they can all have +1 charge. Well, only magnesium can have +2 charge. Okay, when we compare the sizes, we know that rubidium lies in group 1. Okay, and it lies at the, it lies at the highest period. So rubidium will have the highest size. Okay, then it would be potassium, then it would be sodium, and finally it would be magnesium. So you can see that magnesium has the highest charge and lowest and the smallest size. So the charge to size ratio of magnesium would be the highest. So any answer would be either option B or option D. Next is sodium. Sodium, potassium, rubidium, they all have the same charge. Okay, so the smallest one between sodium, potassium, and rubidium will have the highest charge to size ratio. Okay, or the highest charge density, and we can say that sodium has the smallest size between these two. So after magnesium, it would be sodium, then it would be potassium, and then it would be rubidium if we compare the sizes. So option D is the correct answer to question 12. So in the next question, we need to identify the enthalpy of formation reaction of ethanol. Okay, so for any enthalpy of formation reaction, we should see that only one mole, okay, or only one molecule of product should be formed. So by that analogy, option B and option D won't be correct. It would be anything between A and C. And also for enthalpy of formation, the product should be formed in the same form as it is obtained naturally. So ethanol is obtained as a liquid. So option C is the correct answer to this question. So in the next question, we need to actually calculate this delta H3 in the terms of delta H1, delta H2 and delta H4. So we would just be applying Hess law. So Hess law says that if you add the enthalpies of the intermediate reactions, it would be same as the total enthalpy. Okay, so that means here delta H1 would be equal to delta H2 plus delta H3 plus delta H4. Okay, so we are starting from here, we are ending from here. So I can go via this way. Okay, from this way it is delta H2 plus delta H3 plus delta H4. That is the total enthalpy change. Or I can directly come from this reaction to this reaction with enthalpy change delta H1. So we need to find delta H3 because enthalpy change for hydrogenation, this step is the hydrogenation step. So delta H3 would be delta H1 minus delta H1 minus delta H2 minus delta H4. So checking the options, option A is the correct answer. So moving on to question 15. in this question, we need to calculate the bond HH bond enthalpy by the given information. Okay. So firstly, we are given the bond enthalpy of formation of H2O. So to convert this reaction to enthalpy of formation, you just have to divide by 2 because H2O should have like the stoichiometric coefficient of H2O should be 1. So the reaction would be H2 plus half O2. That gives you H2O. Okay, so delta H of this reaction would be X. Now we know that delta H is equal to summation of bonds broken. Okay. I mean, there is a bond energy or summation of bond enthalpies of the bonds broken minus summation of bonds formed. Okay. See here, one H2 bond is broken. Okay. Let's say that the enthalpy of formation of H2, okay, or no. So let's move on to question 15. In this question, we need to find out the HH bond enthalpy in the H2 molecule. So let's assume that HH bond enthalpy is let's say it's M. Okay, we need to find out M using this bond enthalpy, and also we are given the enthalpy of formation of H2O. Okay, so to convert this equation to enthalpy of formation equation, we need to make this coefficient 1. So let's just divide both sides by 2. So our reaction becomes H2 plus half O2. It gives you H2O. Delta H of this reaction would be X. Okay. Also, we have studied that delta H is basically summation of bonds broken minus summation of bonds formed. So here, let's see which bonds are broken. H2. Okay. So bonds broken would be M. There is only one H2 bond that is broken. So we have already assumed the bond enthalpy to be M. So let's write M. Delta H is X of this reaction. Half of an O2 bond is broken. So O bond enthalpy is Y. So plus Y by 2 because half of it is broken. Then for Z, see H2O, in H2O, 2 OH bonds are formed. Okay, H2O looks like this. So basically 2 OH bond is formed. So we would be subtracting 2Z. Upon solving, we find that M is basically X minus Y by 2 plus 2Z. When we take out this half common, what we get end up with 2x minus y plus 4z. Unfortunately, our solution doesn't match with any of these options. But what we can assume that here they have missed a 2 in front of this x. Okay, so obviously option B is the closest answer. Now for question 16, we need to find out which of the apparatus can be used to monitor the rate of this reaction. First is a pH meter. We can see that H plus ions are getting generated in this reaction. So what happens as time goes on, the pH of this solution will fall. Okay, so using the pH meter, obviously we can check the rate of this reaction. So option 1 is correct. A gas syringe. Basically a gas syringe is used whenever you have gaseous products or gaseous reactants. Okay, but in this case all of our reactants and products are aqueous, so we can't use gas syringe. Okay. Now colorimeter. Colorimeter basically is an instrument that that can tell you which of the wavelengths of light are being absorbed by either the reactants or the products. Okay, so what happens is this reactant will absorb a set of specific set of wavelengths, and the products will absorb a specific set of wavelengths. So as a result, as time goes on, more of the wavelengths that is absorbed by the products, that would be absorbed more. Okay, so obviously we can use colorimeter to monitor the rate of this reaction. So option B is the correct answer. Okay, so yeah. Now in the next question, we need to find out which arrow shows the activation energy. Now it's really easy. See, the reaction from here follows this pathway. Okay, and if you use a catalyst, then it would follow this pathway. Okay, but here we need to find out for the uncatalyzed reaction. So the maximum energy or the energy that is required for this reaction to proceed towards completion is C. Okay, this point, this energy. So option C is our correct answer because C is the activation energy of this reaction. So C is the correct answer of question 17. For question 18, we need to find out what happens when we increase temperature. Uh, yeah. So obviously, when you increase the temperature, your equilibrium constant Kc will increase. Okay. Now for the equilibrium shift. Now the equilibrium is an endothermic. This reaction is an endothermic reaction. So what happens is it absorbs heat. So when we try to increase the temperature of the surroundings by applying La-Chatelet principle, this reaction will try to decrease the temperature of the surroundings by absorbing more heat. Absorbing more heat means it would shift towards the forward direction or shift towards the right. So option D is the correct answer. For question 19, we need to find out that which of the substance will not produce copper to chloride when added with dilute HCl. Now the answer here is copper. Okay, it's plain copper. It is because copper lies below hydrogen in the activity series. Okay. So what happens is copper won't be able to displace hydrogen from HCl. Okay, this won't fetch any reaction. So option A is the correct answer. In the other three options, we will plain have like the displacement reactions. So that's it. Now let's move on to the last question. In this question, we need to find out which of the acid will have the weakest conjugate base. So we know that stronger is the acid, weaker will be its conjugate base. Here, among all these three, HCl is the strongest acid, so HCl will have the weakest conjugate base. So with this, we finish the solutions of questions 11 to 20 of IBSL 2020 Chemistry Paper 1. And in the next video, we would be discussing the last 10 questions of this paper. So till then, don't forget to like this video and subscribe to us. Thank you so much.